All right, how's it going, everyone? Welcome to another episode of Forward Thinking Founders, where we talk to founders about their companies, their visions for the future, and how the two collide. Today, we're talking to Chris Edwards, who's the founder of Sensory Robotics. Welcome to the show. How's it going?
Thank you. I'm doing very well today.
Awesome to hear. So, for people that haven't heard of Sensory Robotics or that haven't heard of you before, what are you working on? What is Sensory Robotics?
Our goal is twofold. First, to make robots safe around humans. So this is especially for industrial and factory robots that otherwise very big, very heavy, very powerful, and very uncaring of anyone around them. And the second goal is to use that same system to provide some monitoring and data and metrics for the company that owns the robots. We can actually do this through roughly the same system, and it allows those robots to be much more productive than they otherwise would be.
So I guess a few basic questions. I'm not super technical, but like what types of robots are you kind of working with? Is it anything, or is there types of robots? And just walk me through a little bit more of how it works, how like the technology works, if you're open to it.
Sure. The type of robots we focused on most is the 6-axis robot arms. So these are the things that will pick stuff up and move them over, or hold a welder in a car factory and start welding the different parts together. They are some of the most complicated types of robots, but there's different challenges for every type. For these, it is the agility and the amount of motion they can have, which is considered their value point. For others, like a SCARA type robot, those can be amazingly fast. But our system can work with all of them, but we focus currently at the 6-axis.
And why'd you decide to start Sensory Robotics? What's the origin story for the company?
Yeah, the origin story is a bit more personal and fun than it sounds at first, because what me and my co-founder both wanted to do was interact with a robot in virtual reality. So we were making all these fun things, and my co-founder was actually working on a boxing robot. So not a robot that puts things in boxes, but a mobile base with a boxing dummy, so we could have a VR headset on and see a real opponent. And then you can punch out and hit the dummy, and then the opponent moves. Dummy moves with it. So you feel like you're really boxing, except the opponent doesn't actually punch you. That's an important safety aspect, I should add. And so when I saw what he was doing, and I was working with 6-axis arms to do the same type of thing, we started working together and collaborating. And that led us to thinking about how much can be done through virtual reality and interactive robotics, making robots understand what humans are and where they are and what they can and can't do around humans. And that technology pushed us a bit more toward the industrial market because, let's face it, there's not many people who are going to buy a very expensive boxing robot. Especially during COVID, boxing gyms aren't exactly buying something where people will share headsets. So when we got more into the industrial market, safety is a huge, huge focus. And every major manufacturer needs to make sure all their robots and systems are safe, because otherwise it's not just liability, but the amount of danger that a person can be in for an unsafe system is substantial. So everyone who uses these robots must make them safe in order just to use them. Otherwise, they can't buy them. So that's how we got into the safety market.
Yeah, absolutely. That makes a lot of sense, and I appreciate you sharing the story. What have been a couple of things as you've been, entering and starting this company, entering the market? What have been some other things that you've learned, whether it's about how people use robots or company building or working with a co-founder? What are some learnings you've come across, so far?
Yeah, one of the things that surprised us is how little most people interact with robots in their daily life. And if you think about it, for the average person, the most complicated robotic machine they've worked with is probably one of those vending machines that can pick up your drink and then slide it over to the side, then lower it. That's about as advanced as it gets for consumer-facing robots. And then you can also get a Roomba, but it's a Roomba. It's not quite the same thing. So when explaining our system, we have to explain really what factory robots are and what they do, and that they really don't care if someone's in the way. And if they don't care, then they'll keep on moving with about 2,000 pounds of mass behind them. And so that's been one of the things that surprised us. One of the other things that surprised us is how limited the innovations are within the industry. Now, I don't want to say that they're not innovative. They very much are. But most of that's focused on reliability and consistency and replaceability when necessary. So if you had a robot made in the 1980s on your production line, with most makers, you can replace it with a modern one without changing the control code. which is great for the customers because if they need to replace a robot with a faster one, they can just bring one in without interrupting production. But when the industry focuses on reliability, that means they're not doing the upgrade cycle that you see with cell phones or cars or computers. So they don't have a lot of the features and abilities that you might think they'd have, considering how long that industry has been around. So the control systems for them sometimes still run on Windows XP. So, and some of the simulators used to control it are, they have an air of 2002 about them in terms of the user interface and abilities. Still very good, very powerful, and very capable, but it's just not as advanced as you would think.
Where do you think are some of the opportunities for people to innovate in robotics, or predictions for the next 5-10 years, just, specifically just for the kind of robotics in that industry?
Oh yeah, it's a huge field and there's so much diversity, so I can cover a few areas. One is if you're a mechanical engineer or electrical engineer and want to really get your hands, well, not dirty, but still clean when doing them, there is really a market for cheaper robots because a cheap factory robot, 6-axis arm, is going to cost you about $30,000. That's just for the hardware. The installation and programming cost more. So the parts don't cost $30,000 put together. They cost substantially less than that. Don't tell anyone, it's a secret. Between you, me, and all our friends. So there is this market now for cheaper robots. And there's some people, Chris Annan on YouTube, for example, has a kit that is a few $1,000s, all parts include, when you buy all the parts for it. And it can do a very substantial amount. And when you get sort of consumer priced robots, you open up so many more opportunities that just haven't been thought of before. So there is a market for that. For other aspects, for drones, the sky is the limit, kind of literally. Everything that you could want to do with robots, people are making drones do. So that's land surveying, oil field surveying, search and rescue is an application for them. If you think of finding someone after a disaster, that you want to have 100 drones in the air to find them, rather than a few guys on the ground looking and shouting someone's name. And then just coordinating drones to act in a swarm, something Intel is even focused on. And I believe that's been part of the most recent 4th of July celebration in the US. They had some very nice visuals. And for industrial robots, there is still a lot of work that's needed for coordinating robots so they can all work together. Because part of everything being reliable is that they're not often hooked into one giant system within the entire factory. They're individual cells or individual robots. So the coordination between a lot of them is an area that is being focused on. And then, of course, the data mining aspect from any of these robot types. Factories want to know how efficient their robots are, how much more they can get out of them. If they spend 100 grand per robot, they might spend 50 grand on a program that makes it twice as efficient. So there's tons of areas.
And if you were to kind of do the same mental exercise, for what you're working on with sensory robotics, what do you see as the future for what you're building? I guess, in other words, what's the big vision here and what direction are you rowing in every day?
Yeah, the big vision is to enable the robots and factories to just work with humans near them, even side by side, without any concern about contact. The existing safety regulations are very strict on what can happen and what can't. And for the current cobots, collaborative robots that can work around people safely, the restriction is that it can hit a person as long as it doesn't cause damage. It can still actually hurt a little bit because that doesn't cause damage yet. But there's a lot of work towards what we do, which is speed and separation monitoring, which is to prevent hitting. And we would probably, if we're going at it again, focus more on that from the very start than on some of the VR aspects. And so our end goal is to enable factory robots to be completely collaborative and interactive with humans. So if you have a factory assembling cars, there's some parts that are installed by humans, some parts installed by robots. The windshield, robots usually, because it's big, heavy, and one person can't lift it, you need two. But say the rear view mirror, probably humans, because they have to reach into the car and be agile and put that in there and stick it on. So we would want a robot to install that windshield while a person is lining up to put that mirror on. It sounds like such a small thing, but if that is the bottleneck in your production line, that's what's keeping you from making more cars. And if you can apply that idea to everything across the entire production, it's a huge effect. So we see in the end, humans and robots actually working side by side. Robots doing the tasks that require a lot of strength or a lot of precision, and humans doing the tasks that require either human thought, which is what humans are best at, or agility or adaptability for all the variations on car models and trims.
And in order to make that happen and bring it to life, you'll need some help, right? It takes a village to make a startup work. So my question for you is, how can the forward-thinking founders community help? Are you hiring? Are you raising money, looking for customers or users? How can we assist?
Yeah, we are working on some letters of intent from companies we have worked with already. So we can always use more customers, but we just might have some already. But of course, once we get those in, and if we get more customers, we do need to hire people. So people who are good at mathematics and have any experience with robotics, please get in touch. Me and my co-founder started with Raspberry Pi and Arduino robots years ago. If that's someone's experience, that's really a lot of experience, and not that many people actually know industrial robots as much. And so the programming experience, in addition for something like C#, Python, Java, those are things we'd love to see. And if you enjoy just getting your hands on something or seeing the result of what you've done very quickly, like making a robot move, that's great. That's something that just makes us happy every day.
And then if someone wants to learn more and potentially work with you or just learn more about what you're doing, where can they find you online? Do you have a website, social media? Do you have email? How can people get in touch?
Yeah, our website is sensoryrobotics.com, all one word. And that has some of our demos showing us not getting hit by robots that are otherwise told to hit us. So that's our system works. It also shows some things that we can make robots do that no one else can. Like we can mount a robot on a robot and control it in real time. And just, it was a test case to see how much you can try to interfere and mess it up without the system actually having a problem. The system handles it. It's beautiful. And our YouTube channel is Sensory Robotics. We link to it through the website, and that includes some more recent demos that are, I don't want to say endurance tests because it didn't last hours and hours, but we tried to see if we could trip up a robot or just how much we can make it invoke the safety features to make sure it actually works. And it's pretty impressive if you're familiar with robotics and the industrial safety.
Well, thank you so much for coming on to the podcast. I really appreciate it.
Oh, thank you. It's my pleasure.